That's funny, Kamal.
All right, started?
That's really funny.
So stoichiometry.
Big word. You want to show
So stoichiometry is the calculations that we relate to chemical reactions, and it is important in industrial applications because it allows us to see how much we use and how much of the products we produce. And it is very heavily tested on in the Chemistry Olympiad, so it's important to know for that. So first of all, I'm going to go over something called dimensional analysis. Dimensional analysis is something that we use to convert from something to something very efficiently, and also check our work on the way. It's really, really cool. So this is one of the problems that I just came up with. So what we're going to do is, it says 1 bop is 2 cups, 5 cups are 3 lops, 7 lops are 5 gobs. How many gobs are 8 bops? Right?
Those are Turkish.
They are not.
Turkish currency, guys.
So first of all, we look at what are we given? 8 bops, and also our conversion factors. So these are what we call conversion factors. We're going to use our conversion factors to go from bops to gobs. So first of all, we write what we already have. So we have 8. I'm just going to start with the first letter. I'm not going to write the whole thing. I'm just going to say 8B. So we are given 8 bops. So what we're going to do is we're going to create a conversion factor, give it as a fraction, and we're going to turn this into whatever we can. So we know that 1 bop is 2 cups. So I'm going to do 1B is the same thing as 2K. Don't forget, a fraction is, I'm multiplying this by 1. Because 2 cups is the same thing. It's equal to 1 bop. So we're not changing the value of this. We're just changing the units. So we go from 1 bop to 2 cups. We're going to go from 5 cups are 3 lops. Everybody good so far? So we're going to go from 7 lops are 5 gobs.
I wonder if someone just walked in right now.
No.
Advanced
Ignore that joke. Anyone have a calculator?
Do it in your head.
Okay, fine. 18, or 16 divided by 5 is 3.2.
No, 5 cancel out.
9.6.
I mean, the 5 cancel out, so then you just take 3 over 7 times 16.
Okay.
3 sevenths of 16.
48 sevenths.
Is Conrad better than you in math?
You know what? I'm better than Kamal at a lot of things. It's no surprise.
That's a lie. So 48 sevenths lops are answered. So that is...
Wait, so...
Should also say how the units cancel out.
Yeah,
Yeah,
that's essentially what we're doing. So the B was on top, so the B at the bottom is going to cancel out. K is up top. This is going to cancel out with what's at the bottom. The L is going to cancel out with this L, and we're going to be left with this guy. And
yeah, so just to visualize it, this might help some people. So these things just cancel out, right? So the on top cancels out the bottom,
Didn't you just
okay.
spray the stuff on the board? I don't think it's a good idea to write.
where is the...
And then, and then
The
you're left
cloth.
with that.
Oh, it might be under the PowerPoint.
Oh yeah, it's here.
Nothing.
No, he dropped it. It's okay. Alright. So, okay, the main principle in stoichiometry is you always convert everything to moles. Moles are what's going to get you in and out of converting anything. So, I know that I just gave you a really, really general thing, and you're probably, not probably, I don't want to say that, but you're confused maybe. And so this is an example that I'm going to do that hopefully will help. So, what we're trying to do is we're converting grams into grams. So we're given this reaction. So what we're going to do is we're going to convert 5.0 grams of silver So when we're trying to convert grams into moles, we always look at the molar mass. Because don't forget, 1 mole of a substance is, that was great, it's molar mass grams. So 1 mole of hydrogen is 1.008 grams. 1 mole of titanium is 47.87 grams. 1 mole of silver, which is what we're trying to do, is 107.87.
And does everyone know what a mole is?
Yeah, come on, go over that.
Oh, okay. Sure. Let's write this real quick. So you know how we have a dozen eggs? A dozen eggs is 12 eggs. A mole is a number that we use like that in stoichiometry or in chemistry in general. Avogadro's number, you're right. It's 6.022 times 10 to the 24th. It's a very big number.
Wait, 23rd.
Yeah.
Oh wait, yeah. I'm dumb.
That's
Sorry. I just did the stoichiometry problem. Maybe
it's
kept
alright.
it. It's all
Everyone makes
good.
small mistakes. Let's continue.
It's all good.
Yeah. So
Okay.
the 23rd to the 24th is avocado's number.
So this is our number. This number is just a mole. If you have a mole of watermelons, you're going to have 6.022 times 10 to the 23 watermelons. It's just a number. But it's significant in chemistry in that we can convert from grams to moles, because 1 mole of a substance is its molar mass grams of that substance. So when we're converting to moles from grams, we can do, okay, we have 5 grams of silver. 1.87 grams of silver is 1 mole. We know this ratio because 1 mole of substance is that many grams, because that's molar mass. So we're going to convert from, okay, well, so the mole is very useful here. We're given 2 moles of silver, make 2 moles of silver chloride. So that's very useful to us because we can use moles to turn from one part of the chemical reaction to another, yeah?
So is it implied that the unit in the example is moles?
I mean, it's just a ratio. So you're given 2 makes 2. So if you have 2 silver atoms, they're going to make 2 silver chloride compounds, or ion, or not ions, but 2 silver chlorides. So if you have 10 of these, how many of these do you have? So because 2 makes 2, 10 makes 10.
Okay.
All right?
So we're just like using moles here because it's convenient.
Yeah, it's a ratio. Yeah.
Okay.
So then we have moles of silver, and we're given 2 moles of silver. Makes how many moles of silver chloride? 2 moles of silver chloride. Now usually you won't need to write this because 2 divided by 2 is 1. I'm just writing it so that we can see how we convert it. And then finally, it's going to be a little bit harder. 1 mole of sodium or silver chloride is, does anyone have a calculator open? Or again, I can do it in my head real quick. 107.87 plus 35. 143.32.
Yeah. So basically, you take the molar mass of silver and the molar mass of chloride and add them together, and you get the molar mass of silver chloride.
So yeah, I forgot to emphasize that molar mass of any, or don't forget, 1 mole of any compound is the molar mass of that compound. Ooh, thank you, Alex. So we just put this in a calculator to get
More than
we
5.
get 6.64, but okay, 6.6 grams of silver chloride. Any questions, or does that make any sense? Help me here. So, what? Yeah, sig figs are. Sig figs, they are
right, but
sig figs.
There's no 6 figs in the question. Oh, wait, no, there are 6 figs.
Yeah, there is. It says 5.0.
Eric,
Wait, does everyone know what sig figs are?
I went over the first meeting, but I don't know.
Some people might not have been here. Come on.
Long story short.
I wasn't. What?
Do we have any questions here?
Wait, hold on. How did you get the 14,332?
Oh, that's just the molar mass of sodium or silver chloride. You just add the molar masses of silver.
Oh,
chloride.
there's a decimal in there
Yeah,
somewhere,
yeah,
isn't
that's-
there?
Oh yeah, this
Where is
a
it?
decimal.
Oh, okay, that makes more sense.
Yeah, that would be kind of not okay.
It'd be a lot more than 6 point whatever. 6.6.
So is that okay?
Yeah.
Okay, so this is something that will annoy a lot of, like, it annoyed me a lot. But limiting reactants, when we are, when we think of it like this, Miss Kingstreet has the best analogy. She's like, if you're making a cake, you need 1 egg. Let's say you need 1 egg, and you need 2 cartons of milk. And if you had at your house 8,
Use a pencil.
I'm not penciling on the board. Okay, we have 8 eggs and 8 cartons of milk. If we need 1 egg and 2 cartons of milk for 1 cake, how many cakes do we make? So, okay, let's say, because we know that we need more eggs, we can do, let's say this is a M for milk, 8 cartons of milk, and then AE for eggs. What you can do is for 1 C, or 1 cake, you need how many eggs? 1 egg. Or 1 egg. And then for 1 C, you need 2 eggs. Because, I'm sorry, I'm really getting these confused. 2 M, 2 cartons of milk. When we multiply this out, we see that we can make 4 cakes with the amount of milk we have, and we can make 8 cakes with the amount of eggs we have. So what this gives us is it says whichever one is less, that one is at most we can do, because then we run out of milk. We still have more eggs, but we run out of milk. So this is the amount of cakes we can make. So what we say is because the milk limits, we call that the limiting reactant in a reaction. And the eggs are in excess because we have more than we need because the other one limits. So I'm just going to show an example. But if we're given a reaction, let's do the other one. 2 Yeah, I am really oofing right now.
Gotta get some new markers.
I think the board needs to be dry before you can use it.
Does it?
Yeah.
All right. Yeah, it's really not
Chapman
working.
needs some new markers, I guess.
No, I don't think it's the markers.
It must be used.
Here, do you want to pull up the periodic? Do you want to get rid of the periodic?
All right, this works.
Okay.
2AG plus COH.
Okay, I am not doing so hot, but that's okay. No,
You're doing well, Kamal.
What?
Yeah.
It's really not
It's
working.
not your fault.
You need emotional
support.
Chapman, do you have other markers?
What's wrong with that?
The markers are all fine.
The markers are a little.
So I got
Are you erasing the word?
It's,
If you erase it with this, it needs to dry out.
Right.
Mark, so
Yeah.
mark on it.
I get what under the marker.
What do you want?
what? Thank you.
Then throw away any of
Yeah. I'll check with them. Oh. Okay.
I like that.
Yeah. So this is the reaction that was given to us in the previous thing. So if we say that we have 4.0 moles, I'm going to go moles just to make it a little easier, of silver and 4 moles of the chloride, or the chlorine gas. How can we figure out, if we are given amounts of both, by the way, in a chemistry problem, if they give you the amounts of both reactants, you should probably assume that one of them is going to be limiting. So we can't just use the silver to figure out this guy. We can't just use the chloride, or the chlorine. So what we have to do is we have to actually do both. We have to do the same calculation for both and see which one's less. The one that's less is going to be our limiting reactant. So if we have 4.0 moles Ag times, we can see that 2 moles of silver to make 2 moles of silver chloride. So what can we figure out here? We're gonna make 4 moles of silver chloride. So we're gonna do the same thing for the other one. So it's gonna be 4.0 moles of CO2 times 2 So when we do the calculation for both of them, we see that the chlorine gas, if we do the calculation, we get 8 moles of silver chloride. If we do the calculation for silver, we're going to get 4 moles of silver chloride. What we can deduce is that this guy, because if he could make less, or if she could make less, it's going to make this amount of silver chloride, which is less than the other one. So we can say that this is, so silver, in this case, is our limiting reactant, and this is going to be the result of our stoichiometry. So if we're given 4 moles of each, we know that we're going to make 4 moles of silver chloride, and after the reaction has been completely over, after it's completely done, we're still going to have some chlorine gas left, because not all of it's going to be used up. This is going to, all of the silver is predicted to be used. Is that clear? Any questions?
It's kind of dark in here.
What?
It's kind of dark in here.
Is that
Almost
what
like
you
the
see?
lights turned off.
Yeah, you can turn the lights on.
Oh my god.
There it is. Yeah, I turn the lights on. Yeah, it is kind of dark. I'm blinded.
Okay, so this is basically basic stoichiometry. So this is what you need to know now, is that you know that first of all we convert to moles and then use the ratios given to us in the reaction to convert from mole to mole and then go from whatever we want, whatever we're given, to whatever we want. So there are random things that I just put in there. If we have a gas, then 1 mole of it at SDP is standard temperature and pressure, and it's 0 degrees Celsius, 1.0 atmospheres of pressure. So 1 mole of any gas at STP is always 22.4 liters. If it's not at STP, that's different. But a gas, so if it says, if it gives you a reaction, and if it says you're given this many grams of this reactant, what's the volume of the gas you're going to produce? Then you're going to go from grams, I'm just going to do the units real quick, times however many grams is a mole. 1 mole is going to be X grams. Then we're going to go from moles, because then we're going to go from moles to moles, because we're given the mass of 1 part of the reaction, 1 compound or 1 atom in the reaction, and we're going to go try to figure out what the volume is of the gas. Bless you. We're going to go from moles to moles, so what we're going to go is we're going to go from the mass that we are given, then we're going to divide that by the molar mass to figure out how many moles we have. We're going to use the mole ratio to go from given moles to the moles of what we want. And then finally, we're going to say, because what we want is a gas, we are given that it's a gas in the reaction. By the way, it'll be like, at the end of the gas, it'll do this. It'll just say parentheses G. And then 1 mole of that gas, because we're given in the problem that it says STP, it's going to be 22.4 liters. And then when you multiply, this is going to be your answer. So 1 mole, again, I put 24. I don't know what's wrong with me today.
I don't know what's wrong with you. That's all.
I mean, I don't think it's just a today thing.
Yeah.
No.
24 just seems like a better number.
Come on.
It does, right?
I mean, 22 is a prime. Don't know how you can get better than that.
Primes are not
Yeah,
great.
primes are not good.
Yeah, I'm still salty about that Riemann hypothesis. Okay, to convert, yeah, as I said, just use molar mass, and then, okay, so this is cool. Chemistry students will know this as Pivnert. Pivnert is the ideal gas equation, and it is huge because you can convert, if you're given 3 of PV, N, or T, you can go from, you can use those 3 to find the unknown. So PV, N, R, T.
Do you remember what R is?
Yes, I do.
Depends
So
on-
pressure, we just had their gas unit. Pressure is P, and it is in units of atmospheres. So at sea level, the pressure is said to be 1 atmosphere, so at the sea level. So because we're a little bit above, our pressure is a little bit lower than 1 atmosphere. Volume is going to be in liters. N is just the number of moles. So gases are cool because when ideal gas equation assumes that all of the gas follow something that we call the kinetic molecular theory perfectly. So, and no gas does actually, but it's just a good estimate. So moles is the amount of moles we have of that gas. And for any gas, chlorine gas, it doesn't matter if it's argon or hydrogen gas or helium gas, all of those are always it doesn't matter the identity of the gas. These will always work for any gas, any given gas. So helium, this will work. Carbon tetrachloride, carbon dioxide, water vapor, all of these will work.
I love carbon dioxide.
So
because
N
it's gonna
is what we
produce
call the
global warming
ideal
and
gas
emissions.
constant. The
I won't need this
ideal
one
gas constant is just a constant that we use. So first of all, temperature is going to be in Kelvin, always.
How do you convert from Kelvin to Celsius?
Okay.
Kelvin is an absolute
Degrees
zero
Celsius
scale.
plus 273 is Kelvin. So to go from, so it's just a shifted Celsius scale. So if you have 0 Celsius, then you're 273 Kelvin. And then R is 0.08206. And then, and then there are these units that doesn't really matter.
ATM meters over mole.
No.
Sorry, 0.806, yeah.
Yeah.
That is correct.
So that is our ideal gas constant. So if we know any of these, we can figure out how many moles we have. So in certain stoichiometry problems, what they'll be like is, okay, here is a gas. We're not going to give you the number of moles. We're going to give you the temperature, we're going to give you the volume, we're going to give you the pressure. All three of those things, you can just plug them in here along with the constant to figure out the number of moles. And that's the number of moles you can use in your ratio. That's the number of moles you're going to use. Is that clear? Any questions?
What's an ideal gas?
And okay, fine. So the kinetic molecular theory assumes a lot of things from a gas. And it's just a theory. But it says, for example, when they collide, they won't stick. All their collisions are perfectly elastic. So they'll just bounce off each other with no attraction or no repulsion from each other. So there are certain criteria like that. And if a gas follows all of those perfectly, then we call that an ideal gas. Eric, no.
Wait.
No.
Just something quick.
Nope,
right?
we're good.
This is asked a lot on
Here.
Alright.
like it's like
If
what-
they have that question, they can ask.
No,
not
what
you.
is a gas most like an ideal gas? Remember that question?
Yes.
They don't need that now. They don't
You
need
don't need that right now.
You should explain.
We'll do that when we go over gases.
Explain
What is a gas?
Why are you telling me what to explain? I have this ready.
Explain why pigment works, like how the things are.
Okay. So I put 3 problems from the Chemistry Olympiad on here, and I don't know why I put the answers on the same slide. I'm great. So this was actually from last year, and I think it's like the only question last year on the Chemistry Olympiad that I just did not guess at all on, and it was the only question I actually got right. That like I didn't guess on. No, I got 30 right out of 60, but the other 29, there was at least a little bit of guessing involved in every single. So, how many oxygen atoms are in 225 grams? Oh, shoot. You guys want to try this by yourself?
I'll try myself on the board.
No.
30 out of 60 is really good, by the way. Like,
Yeah.
first place 2 years ago was 43 out of 60.
And by the way, should I tell them the molar mass of oxygen?
I mean, they can look it up.
Is it multiple choice?
Yeah.
It's all multiple choice.
It's all multiple
The
choice.
questions are
Can
insanely
we
hard.
round
Or
the molar mass?
Yes.
Like
So you just use
Just
for
use
the
like
just use
16.
16.00. Just
Yeah.
use 16.
Well, it's 02.
It's
Yeah. So because
And then
so
it
you're
would
gonna
be
multiply by 2.
32.
Yeah.
Well, I was just gonna tell them,
But you know what?
but you ended up telling them anyway, so it didn't matter.
But I'm giving the talk, not you.
Conrad, why don't you do it from the top?
You know what? I think I can do this one better than you.
Aw.
Go back to your management position.
Conrad,
I don't-
Conrad, if you do want to give a talk, we're willing to let you.
You should go over like.
Oh, I'd love to make fun of
You
them.
should go over like.
I learned the
radiation
topic and I just
stuff.
think of a
Fine,
bunch of things.
I'll do a
that
topic.
mess
Like,
What do you guys want me to do?
Beta, alpha radiation.
Oh,
No.
Positronic radiation? I'll do it.
I got it.
I'll do a talk. I like it.
Okay. Is anyone ready? Is anyone done?
Find it.
I need an
Oh,
answer.
is it?
Oh,
What?
Do I want to?
Ooh.
No.
Okay.
Fine, I'll do it.
Oh, how many atoms? I said how many moles. Okay.
So don't
Okay.
forget, you have to multiply by what is a mole? 1 mole is 6.022 times 10 to the 23. So that's the number that you're going to use. Other freshmen, hi. Are you guys good? Ready? So, what did you get? 4.2? Okay, a mole is this much.
You should just keep it on the board. No.
Okay, I think it's A.
It is not A.
Okay.
I gave the answer. Oh, no, wait, I didn't. Oh, I thought I gave the answer. I thought I said D is the answer. No, I didn't. I actually have to figure this out now. 32.00 grams.
Technically, it's 30.
Conrad, stop. Thank you.
Well, you have to be more precise. Isn't precision a big thing in chemistry?
If you're not,
It is,
if
not right
you're
now.
not precise, then you're not gonna get the right answer. It's 29 point. Oh, I'm missing 31.
So this is the calculation you should have used. So first we go from grams to moles by dividing by the molar mass of the oxygen gas.
Oh.
And we get number of moles, and we know that 1 mole is this many atoms of oxygen. Or molecules, sorry.
Wait, so what is
Nope, stop. Thank you.
Shut him down, come on.
No, if you think about it, it's diatomic. So
It's
it
what
says-
my country does
It asks
to
the
journalists.
questions. It asks the questions in atoms.
Yeah, the answer is A. Sorry.
Wait, but come on. Is that atoms of O2?
Yes.
Or atoms.
molecules.
It says atoms.
Synchronous.
I swear. No.
Wait, so would you multiply by 2? Or do you not?
Oh yeah, that's actually a good question. Alex? So we got there are yeah, you would multiply by 2, sorry. We got a number of moles, and then because this is how many oxygen atoms, you have to multiply by 2.
Yeah.
Yeah.
Which means the actual answer is C. Conrad for the win.
I think so.
Yeah, I think that
because
was
it says
oxygen
atoms.
molecule.
It doesn't say well.
It's oxygen atoms, not molecules.
Yeah, so you multiply by 2.
So the actual answer is C.
So the actual answer is C, they're right, because it says how many, so this is how many,
So did you just get B?
can you guys stop, please? Give me a second. So this is the number of molecules. What we're going to do is, because there are 2 oxygen atoms in this number of molecules, you're going to have to multiply by 2 to get C.
This actually makes sense.
Didn't you already multiply by 2?
That's for the molar mass. Yeah, that's for the molar mass. Because for the molar mass, to go from grams to moles, you have to divide.
I suppose in this case, then you could just forget multiple.
Okay.
Alex, don't confuse them.
Don't confuse people. And usually you're the one who's telling me that.
Yeah.
So,
Alex is actually right. You could have just done 16 and then not.
we know.
220.
So this is something that I have to give you something for. So the combustion of C3H8 is a reaction that I would have to figure out real quick.
It's reaction type.
No
Yeah,
way.
Hey, don't you just add, don't you just react with oxygen?
Equals.
Conrad, I need you to stop right now.
Decimals in the long
And then like, and
You know what? I'm gonna do my own lecture on the other side of the board.
then 1 would be equal
No, you're not.
to 3.
Wait, no, I just realized.
No, that's right here. It's not five. Because
Because you
I
know how
know.
much grams
Oh,
is
you
in
know,
one
but you
mole.
still did it
You're
wrong.
gonna be finding a number, right?
10
And then, yeah, and then you know how many
It's,
atoms are in 1 mole, so you would
it's 6
multiply by like
Look, the freshmen are actually involved. You're not. Thank you.
times.
Love you, freshmen. Wait, I can't believe I just said that.
That's H2O.
Someone kill me.
So that's 8 H2O. Wait. No, 4 H2O. Oh yeah, 8
Just write
H2O.
down all the molecules first and then add numbers.
It's okay. I told
You
him.
can like cancel everything out.
I know. You gotta give me a second, guys. It takes a little while.
20,
Come on, you were right the
11.
first time. It was.
But I got 40.
Ooh. First one would multiply by 10 to the power 24.
Sometimes Kamal gets
Times
so high.
6.0.
Chemistry
He
is-
like all the advanced stuff, but he can't do basic stuff.
That's always my problem.
Explain
Okay.
Schrodinger's equation.
Stop. Okay. So this is the combustion of. This is called propane. So propane is C3H8. The combustion we'll go over reaction types later.
Combustion.
But right now,
creates
stop.
Ready?
Yeah, that's true. Combustion is fire. This is we're literally burning this right now. So this is the reaction that I want you to use to do that real quick. No, I don't know what happened. So just you're gonna go from grams of C3H8 to moles of O2.
Should do mental.
Why isn't this talk?
Eric, what are you doing?
Michael. Yeah, I'm just there for fun.
2.2 divided by
Carbon
12.1.
is 12.011.
What?
1.0. Wait, so it's
Wait,
36.
give me 1 second.
That's 44. 2.2 divided by 44 times 5. Oh, wait, is that it? 2.2 divided by 44 times 5. 2.2
Okay, I'm actually gonna do that.
That's right, 1.1 over.
What? Those guys gave up on us.
That's 1/22. Basically 1/22. Which is basically 0.05. Which is basically 0.05 times 0.25. It's like approximately 0.25.
Wait, where does he get the 44 from?
That is the molar mass of propane. So you have to figure it out using the periodic table.
You add them all, right?
What?
You
You add up 3 carbons and 8 hydrogens.
Okay.
See where?
No, I know where I went wrong.
Testing testing out of chemistry is not that bad. Like it's not as hard as they put it.
No, yeah, no, it really
It's
is.
not as hard as they put it.
It really
They're
is.
gonna be like, oh, we're gonna make it harder than the
Oh
final.
yeah, do you
section.
remember when the teacher stayed up like only about 2 people pass every year, and then
Yeah.
a group of 6 people all pass?
Oh, with over a 90.
Yeah.
Good job.
Yeah.
How many?
Oliver Go gets a 99.
It's okay. Has anyone done it? Has anyone got it? Bless you. Wait, why did I say
He
that?
got it. He got it.
I did in my head.
Did you guys got it?
So
Did you
the
not?
5, okay, you put the 5 there because 5 to 1.
Let's
Okay,
go through it.
alright.
So this is the grams of propane that we are given, right? Hey, Pranav.
Yeah.
This is the grams of propane that we are given, right?
Yeah.
So we're going to divide that by the molar mass to get how many moles we have. So see a pattern. Always we are converting from whatever we are given. So if that's liters, we convert to moles anyway. Whatever we are given, we convert to moles. Moles, so I like to think of stoichiometry like this. You are given a bunch of lines, and these are all different units. But they all intersect at one point, and from that one point, a bunch of different units emerge. That one point is moles. We always convert whatever we have to moles, and then we use moles, and we use these ratios that are given in this reaction to go from the moles of this guy, which is propane, which we are given, to oxygen, is what we want. Moles are pretty universal, yeah. So, do you guys have anything? Like, I'm gonna go over the calculation real quick. So this is how many grams of propane we're given. From propane, we are going to divide by the molar mass in order to get the number of moles. Stop, please. Cormac, count out, please.
I can't believe you called it.
So we're going to go from grams to moles. And then we cross out the go from the moles to the moles of oxygen because it asks for how many moles of O2. So we go to moles of O2 and we use the 5 because of the ratio. So when we do this calculation, theoretically we should get the answer, but theoretically is always true.
Approximately 0.25.
Percent yield too.
Yeah, it's 0.25. C.
Come on, what's the other non-stoichiometric compounds?
What? It's not a thing.
Yeah, it is.
Chemistry Olympiad.
Look it up.
I know.
Propane is non.
So this last one, you know what, being the dumb me, I said, hey, let's do a really hard one.
Oh no, big.
But it's like, I don't even know if it's good or not. Alright. No, I don't think we can do this.
Oh, no.
1999.
This is old. I went through 20 exams just trying to find good stoichiometry problems. And I said, why don't we try this?
Wow, that sounds like 20.
Keep doing, keep doing.
Oh, this one's not too bad.
That's 20 years.
What is the
What'd I do?
Okay, I think I got it.
Just set it up.
What do you mean you got it? Let me do it. I'll do it on my own.
No,
Set it up. Set up the equation.
give me a second.
You know, it's just algebraic, right? So you just say
1 mole of M equals.
If you don't know it's 1 mole.
Oh.
You got 0.2. Do you mind if I?
Go for it.
0.25.
Conrad, you should make your own PowerPoint.
You know what? I will next time.
All right. I got it.
Kamal should boss you.
No, I got it.
No, I got it. Next time, I swear I will not let him.
Yeah, don't let out. Yeah.
Yeah, I will not. Okay.
It's not working.
Go with me. You gotta go. Ready? Seat, please.
Oh,
Thank you. So we can set up a quick ratio. We can say, okay, so we have our element M. So for 1 M, because we have 6 fluorides,
It's a capital M, come on.
that is a capital M. It's my capital M.
According to the PowerPoint.
Oh my gosh, that's a
Conrad.
Conrad, this is genuinely getting really annoying. Thank you. So we have 1 M to F ratios are 1 to 6. So we are given that we have this many grams of hexafluoride. Ooh, I'm great. So we're going to subtract M. So okay, we are given that many grams of the hexafluoride. What we're going to do is we're going to subtract how much we have of M to get how many? 0.297 grams of M. Because we subtracted, sorry, not M, grams of fluoride. So this is the mass in our 0.547 due to fluoride. So we're going to convert this into moles and then divide by 6. So let me just do that real quick. Not grams, moles, I know. Can you tell me the mole mass of fluoride?
It is
19.
Sure, let's go with 19.
It is 19 actually. Good job. Good job.
I don't know. No, I don't know if it's how
It's
works.
19.
All right. Whoa, I'm done.
Here, come on, let me do it.
No, Conrad, you're not doing this. I haven't done this
Keep
wrong.
calling him Cormac.
You know what? They're basically the same. Just kidding.
No, I was actually supposed to fourth grade.
Because of famous magician, Kermit.
Yep.
Isn't
I'm
that the
famous
brand of
magician, too.
spices that they sell at Myers?
Yes, I got my cord tricks right here.
You got a card trick the first time.
I got my cord tricks right here, okay?
So, okay,
Stop.
guys, this is thank you. Okay, so this is the mass of fluoride we have, and we're going to convert that into moles to get. I'm sorry, my handwriting got a little too messy. .0156 moles. So this is the moles of fluoride we have. Or one. Oh, sorry. This is the moles of fluoride we have. What we're going to do is, because we know that there's 1 M for every 6 fluorides, we're going to divide that by 6. And I'm not going to write it. Sorry. 0.0026 moles. So this is the moles of M I have. This is a weird problem, I know, but is everyone following? So this is the moles of M we have. So what we're going to do is, we know that we are given this many grams of M, correct? So we're going to go from that many grams, 0.250 grams of M, equals this many moles, so 0.0026 moles of M, times 1 mole of M, is, we don't know how many grams it is, correct?
Yes.
X grams of M. So we basically have a linear equation. 0.250 equals 0.0026 times X. So I'm just going to quickly do this. We're going to divide both sides by 0.0026 to get 96.15. So X is 96.15. So we know that this is how many grams for every mole there are. So this is our molar mass essentially. So times, I'm just going to do divided by mole. So this is our molar mass. So I am going to hope that when I go here and I look up 96, so it should be MO, molybdenum. So B. B should be our answer. I'm hoping everyone followed, because I barely followed myself.
You have any more problems for us?
No, that's it.
That's the end?
That's the end. Woo! I hope that went okay.